Hello, so today we are going to do this problem, which is part of Leetcode October Daily Challenge, continuous subarray sum. So the problem says we have an array of numbers and an integer k, and we want to return true if numbers has a continuous subarray of size at least 2, such that the elements sum up to a multiple of k, and if not, we return false. So basically multiple is just that it's divisible by k. So x is equal to n number multiplied by k, right? So let's take a look at the first example. Here 2 plus 4 is equal to 6. So that means 6 modulo 6 is 0, so 6 is divisible by 6, right? Obviously, and so we return true. This second example, it's the entire array, so we get the sum 42. 42 is divisible by 6, and so we return true. Here, you can try multiple subarrays. You won't find something that is divisible by 3, so we return false. One thing is, when we look at the constraint here, it's 10 to the power of 5. So that tells us that we can't do n squared. So we can't do a brute force solution where we get every subarray possible, calculate the sum, and check if it's divisible. That won't work here. So we need to think about a different way of doing this. Yeah, so let's get started. Okay, so let's see how we can do this. So let's just write down what we want. What we want is a subarray from I to j, and I can be 0, j can be n minus 1, or any index. Each can be any index in the array as long as I is smaller than j, right? Because we want the subarray to be valid, right? If j is before, this is the start, this is the end. And also, like, we want them to be, the difference to be 1, because we want 2 indices, right? Because the problem says at least 2 elements. And what do we want from this I and j? We want the sum, let's say the array is A, from I to j to be divisible by k. What does divisible by k mean? It just means modulo k equal to 0, right? Okay, so that's a good starting point, but since we said in earlier that O(n squared won't work, so we can't really generate all possible subarrays, all possible I and j indices, because that would be O(n squared. A possible O(n) is if we can somehow convert this into a formula using up to I or up to j, right? And up to j. Why is that? Because let's say I and j here. We can keep a map, right, of these prefix sum we've seen so far, right? And the index it ends at. So for example, here we see 23. We can keep a either 23 itself. So we can keep 23 itself and say that the index there is 0, right? The ending index. 23 plus 2, we can say 25. The index is 1, right? And so it's easy to keep the track as we do an O(n) for loop. It's easy to keep track of the sum that ends at I, right? So that's one thing. But what we want is actually the remainder. So how can we do this? So one thing you can realize is, well, if you do 23, if you do maybe 5 plus k equal to 6, right? 5 plus 6 modulo k is actually equal to 5. 5 plus a multiple of 6, let's say 6 multiplied by 2 modulo k, which is 6. So this is k, by the way. K is equal to 6. That's equal to 5 as well, right? So what this means basically is, if you have some remainder or some number, right, plus k multiplied by some x value, let's call it, I don't know, maybe b, if everything modulo k is equal to num, right, that means is equal to num, that means that this is divisible by k. Let me write it differently. So if you have a number, right, plus another number d, and everything modulo k is equal to nums, right, this tells you that d is divisible by k. Because, why is that? Because when you add a multiple of k to a number and you mod it by k, you will get that number. So the only way you get that number is if whatever you added here is divisible by k, right? So this is the main thing that we will use in our advantage here. If a number plus another number modulo k is equal to a number, that means that that other number is divisible by k, because it got cancelled out in the mod here, right? So that's the main idea. Now, how do we apply it here? So for the sum of numbers from I to j to be equal to modulo k to be equal to 0, what this would mean is that the sum of I up to j up to I modulo k is actually equal to the sum of I up to j modulo k. Why is that? Because, well, what is sum of I to j? So let's think about why. So we know that the sum of I up to j is equal to up to j minus up to I, right? And that means also modulo is equal for both, right? For this to be 0, right, we need this to be 0, right? Which means basically we need the sum for I up to j modulo k to be equal to the sum of I up to I modulo k to be equal to 0. Okay? Yeah, to be equal, right? Not equal to 0, but to be equal, because their sum modulo k is equal to 0. That means they are equal modulo k, right? So for this to happen, we need this. Okay? So instead of looking for this because it's O(n squared, let's just use this. And by the way, the constraint here for this to be, this formula here, is that I is smaller than j. So how do we look for this? Well, for each index, just record the sum you've seen, and then as you go forward, which is looking at future j's, check if you've seen it before. If you've seen a reminder, the same reminder before. If you've seen it, that means you have this formula valid, right? Because if you find j such that the remainder you've seen it before, which means there is an I you've seen before, that means I to j is actually modulo k is divisible by k, right? So that's pretty much the idea here. The only thing we need to think about is the constraint of the I to j needs to have a length of 2, right? So that means in our map, we need to record what is I, so that if we find it, we can say, okay, j minus I needs to be bigger or equal to 2, so that the length of our array is bigger or equal to 2. So we have at least 2 elements. You can also do it in this example and just convince yourself it's right, but with just this formula calculation, it's correct. So let's code this up and make sure it passes test cases. Okay, so let's write down the solution that we just saw in the overview. So what we need is n is equal to the length of, let's just make this a, the length of a, and we need a map to record the sums we've seen so far. So let's just call it scene, right, which is a map. And then let's go through the array elements. We need the index, let's call this j, in enumerate of a, right? And we want to calculate the sum, but in a modulo k way, right? So sum modulo k. So let's call it sum mod k, right? That's what we are doing. So let's call it, so it's 0. So we add a, right, and do plus a, and then we do modulo k, right? So this is basically sum modulo k up to j, right? So this is essentially what we saw in the overview as the sum of a up to j, right, modulo k, right? And then we want to check if this sum already is in scene. If it's not already in scene, right? So we haven't seen, so we don't have sum of I up to a that is equal to this, right? We don't have it because we don't have it because the sum is not recorded in scene, then we just need to record and proceed to the next step, right? So we want to record I, right? Because we want to check the length. Sorry, it's j. This is the index. But if we've seen it, that means we do have it, right? We do have this, which means basically that according to our formula earlier, is that a modulo to j modulo k is equal to 0. That's the only way for this to work. So in this case, we want to check if length is 2, because that's the constraint we have. We need to have at least 2 elements, right? So let's do it here. So if j, which is we want to check that j minus I basically is bigger or equal to 2. What is I? I is just whatever we recorded before in the previous iteration. Okay, so when I check that this is bigger or equal to 2. Okay, if this is the case, then we want to return true because we did find it. So we just return true. We did find it and the length satisfies the constraint, so we return true. If we did all the iterations and we didn't, that means we didn't find the solution, so we return false. Okay, now there's one problem, which is with a case like this, right? So 23 plus 2 is equal to 25, right? 25 modulo 5 is 0. But the problem is that this is the first two elements that we've seen in the array. So scene would not have it, right? Would not have would not have a 0 already. So we won't say that this is a solution, and that's a problem because this is a solution. So how do we handle that? We just need to do a special case when we have the first element as the solution. So that should be easy. So the sum of the mod here should be 0, right? Because 23 plus 2 modulo 5 is equal to 0. So we need to check if the sum of the mod is equal to 0, and at least we have a size of 2, which means basically we need to check that I is bigger or equal to 1, right? So here that would be 0, 1, right? So we want the second index, right, to get at least 2 elements to be at least bigger or equal to 1. Okay, so in that case, if that's the case, we want to return true because we found a solution. It may be also like here, right, from 0 to here, or from 0 to here. So you get the idea. So we just want to handle this special case where the solution is from the starting index. Okay, so that's pretty much it. So let's run this. Okay, that looks good. Let's try more test cases. Okay, let's submit. Okay, so there is a sorry, this should be J, my mistake. Let's do this solution here. And let's submit. Cool, so that passes test cases. In terms of time complexity, we are doing one loop here over A. So this is O of n time. In terms of space, we are only using this map here, which will contain at most all the elements, so O of n space as well. Yeah, so that's pretty much it for today's problem. Please like and subscribe, and see you on the next one. Bye.